Hello, my name is Mr. Hammond, and today's topic of this discussion is graphing quadratic functions. So how do we do this? When a function is written in standard form, which is what we are going to discuss today, which is y equals ax squared plus bx plus c, or f of x is equal to ax squared plus bx plus c. Now this is a standard form of a quadratic function rather than other functions that you may have seen. What we are going to use today is we're going to use a table of values. Now there are a couple different ways you can do this. You can graph. Actually, there's one more that you could add to this known as vertex form. But we are just going to focus on this first using a table of values. So if we move along, what we're going to do first is we're going to kind of analyze the shape that a quadratic makes. It makes a what's called a parabola shape, which is basically just a U shape. Parabola or U shapes are symmetric. Basically means if you fold them along a particular line, in this case, that they would match exactly. So in this case, it would fold it along the y-axis, they would overlap exactly. So the graphs of quadratic functions always are going to create parabolas. So you know that if you graph a quadratic function and it doesn't create a parabola, then there is something wrong with the graph. Something that you see in nature, obviously, that has symmetry is a butterfly. So here we see a butterfly. And then moving along, if we want to further analyze parabola, remember the line of symmetry is the line where you fold the parabola or any shape that has symmetry and they would overlap exactly. Now this line of symmetry, if this parabola were to move to the left or right, that line of symmetry would move with it. So it's just a line wherever you can fold the shape and it would overlap exactly. Now another thing that you will notice with a parabola is that it changes direction at a particular point. This particular point is known as the vertex, as you see here. The vertex is very important because if we know that, we can actually do a lot with graphing a parabola. Without the vertex, it's very hard to find exactly how to graph it. We might accidentally only graph part of it, so just the left side, or may only graph the right side if we do not know the vertex first. So that's actually going to be our focus of this video, or at least of graphing quadratic functions. The first thing we need to learn how to do. Now there's actually a formula to that, as we're going to learn here in a second. So looking at an example, we're going to graph f of x is equal to x squared plus 2x minus 3. So this is just an example. The first thing we're going to need to do is find the vertex. Now there are two things we need to find with the vertex. That would be the x-coordinate and the y-coordinate. There is actually a formula for the x-coordinate, which is the negative b over 2a. Negative b over 2a. Remember that we're looking at this in standard form. A represents the coefficient of the x squared. B represents the coefficient of the x. So if we're looking for the A is kind of hidden, as you would say. Since it's x squared, there's only one x squared, so the A is actually going to be just 1. And then the B is actually going to be a 2. That's a little more obvious there. So we have A, and we have our B. And then we're going to plug that into the equation. So we're going to have x is equal to negative 2 over 2 times 1. Or if we simplify that, we'll find that x is equal to negative 1. And we would plug that into a table of values. Now we need to find the y-coordinate of the vertex. To find the y-coordinate, what we're going to do is we're going to plug what we know about the x for the vertex, which is negative 1, plug it back into this function, and then we solve. So we plugged in the negative 1, which we know is the value of x, simplified, so negative 1 squared gives us 1. 2 times negative 1 is minus 2, or we could say plus a negative 2. And then we have the minus 3 that's on the end there. If we simplify that, we get y is equal to negative 4, and then we plug that into our table of values. So now we have the starting point. So we have the vertex. Now we need to find some points to the left and to the right of this parabola. So if we jump to our next screen, we have our table of values and we have the vertex. So you found the x and y coordinates of the vertex. Now you need to find other coordinates so that you can graph. Keep in mind that parabolas are symmetric. So what we're going to do is we're going to find some points to the left of negative 1, which we could use negative 2 and negative 3, and to the right of negative 1. So we use 0, 1. Now if we plug it, now we're going to have to plug in, just as we did for the negative 1, we're going to plug in negative 3, negative 2, 0, 1 back into that function. So we have here, if we plug in negative 3, and then simplify that, we're going to get y is equal to 0. And if we plug that back into our table of values, then plug in the negative 2, so negative 2 squared plus 2 times negative 2 minus 3. So negative 2 squared, that would actually give me a positive 4 minus 4 minus 3, which gives me y is equal to negative 3. So plug that back into your table of values. And then do the same for the 0. So we plugged in 0. Plug it back into the table of values. And we'll do the same thing for 1. I clicked on those backwards. So we have our table values. Now we just have to graph. So plot those points on the graph and draw a line through them. So here we have the table of values and the graph. So what we would do actually first, in this case I'm going to do it kind of backwards, but we plot the points first. So negative 3, 0. So negative 3, 0. We have negative 2, negative 3. So go over 2, down 3. So there's another point. Negative 1, negative 4. So 0, negative 3. And then 1, 0. So there are the points that we plotted, that we found. Then we would just draw a line through those points. And we'd actually, since we wouldn't actually go off the end of the graph, we would actually draw some arrows on the end, just to show that it does continue forever. But we're just not going to draw it forever. Now, if you have any other questions, please feel free to contact me through the message system, or you can give me a call at 888-805-3741. Have a great day, guys.